Hello. Today we're going to talk about how to find the derivative of the natural log function. So let's write this here, derivative du over dx of ln of x. Alright, to do this we're going to use the limit definition of the derivative, which is going to be limit as h goes to 0 of ln of x plus h minus ln of x all over h. Alright, one way I can kind of rewrite this is going to be by pulling the h out as multiplication. So instead of dividing by h, I'm going to multiply by 1 over h. So 1 over h. And then I'm going to remember some of my logarithm rules. When I have the natural log of something minus the natural log of something else, in this case, natural log of x plus h minus natural log of x, when there's subtraction there, we can combine it into one logarithm that has division. So the ln of x plus h minus ln of x is going to be written as the ln of x plus h over x. Alright, for our next step we're going to do a little bit of simplification. Let me rewrite my limit. 1 over h ln of, instead of having x plus h over x, I can say that this is x over x plus h over x. And that's going to simplify to limit h approaching 0, 1 over h of ln 1 plus h over x. Now I don't really want to deal with that fraction h over x, so let's set it equal to something. Let's say that we can let's call it w equal h over x. So because of this too, because we set w equal to h over x, I can say that h equals wx by multiplying both sides of w equals h over x by x. It'll cancel with h over x and we'll get w times x. Alright, so let's substitute that into my limit equation. One thing we're going to notice here from this substitution is that when, let's get a color out, when h is approaching 0, w is also going to approach 0. So I can write this limit as limit of w approaching 0 of, instead of 1 over h, now I have 1 over wx times the natural log of 1 plus w. One thing I notice about this now is that now my 1 over x is going to be a fixed constant during this limit evaluation, so I can move it out in front. We'll say 1 over x, limit as w approaches 0 of 1 over w, ln of 1 plus w. Alright, another thing we'll notice is by remembering another rule of logarithms is that when I have a constant down in front here as multiplication, like I do with my 1 over w, I can put it to the exponential spot up here, since we're taking it with a logarithm. So that's going to turn into, let's see, 1 over x, let's draw that x better, 1 over x, limit of w going to 0, 1 over, nope, that's what we're getting rid of now. Now that 1 over w is going to go to my exponent spot, so this is the ln of 1 plus w to the 1 over w. So from here we'll notice that my natural log is going to be continuous along the entire duration of my interval from 0 to infinity. So I'm allowed to bring it out in front and take the natural log of that limit. So we're going to have 1 over x ln of the limit as w approaches 0. And that's going to be the limit of 1 plus w to the 1 over w. We remember from some of our limit identities that this entire limit is actually the same thing as the natural exponential function, otherwise known as e. So really this can be rewritten as 1 over x times the natural log of e, which simplifies down to 1 over x. So the derivative of the natural log of x is simply 1 over x.